Okay, so the last type of naming that we have to worry about right now is the transition metals. Remember, transition metals are in the D block. And that would be groups 3 through 12. This is also for post-transition metals, which hopefully you know are the metals in the P block, but not aluminum. So any of those metals, we have to specify what the charge is, and we do that by using a Roman numeral. Otherwise, it can form various charges. So if we look at the first one, we have Fe2S3. So to name it, we would name Fe, which on the periodic table is iron. Then we need the Roman numeral to say what charge the iron has. So remember that when we write our formulas, the charges have been crossed down. So to figure it out, all we have to do is uncross our charges. So if we bring the 3 back up, if we bring the 2 back up, we have iron 3 plus and sulfur is 2 minus. You always have to double check that the minus is correct in case it's been reduced. Sulfur is in group 16, so the 2 minus is correct. So this was not reduced. So the charge then that this iron has is 3. So in parentheses, we're going to put Roman numeral 3. In case you don't know your Roman numerals, I'll list them over here on the side. 1, 2, 3. 1 before 5 is 4, 5. 1 after 5 is 6. 2 after 5 is 7. 3 after 5 is 8. 1 before 10 is 9, and then 10. Those are the Roman numerals you should know. So we've named our transition metal, we've given the charge, finding it by uncrossing our charges. Now we just need to name the anion. So S is sulfur, we change the ending, sulfide. So this is iron 3 sulfide. Next we're going to do SNO, that is not snow. All right, SN on the periodic table is tin. Tin is a post-transition metal. It's one of our metals in the P block. So we still need the Roman numeral. So we're going to uncross our charges. Well, you might be thinking, but there's nothing down there. That just indicates that it was reduced, meaning the charge on the tin and the charge on the oxygen have the same numerical value. So if we look at the charge of oxygen, it's a -2. Which means the tin then had to be +2, so that when it was crossed, it was then reduced to 1:1. So anytime it is a 1:1 ratio, or there's no subscripts down there, the numerical charge is the same for the anion and cation. So this is tin 2, and then O is oxygen, change the ending to IDE, oxide. When we go to cross our charges and write our formulas, it's still the same process. Vanadium 3 bromide, so vanadium is V, and then the Roman numeral is telling you the charge. So anytime you see that Roman numeral, it's always on the charge of the metal that comes right before it. The second element is bromide, and we know it's an element because it's IDE, so we can look for bromine on the periodic table. It's in group 17, so it would have a charge of -1, and then we simply cross our charges. So we would have a formula of VBr3. For number 4, we have copper 2, so our charge on our copper then is +2. Remember, the Roman numeral is the charge on the element that comes before it. Sulfate, ATE, tells us it's a polyatomic, so we're going to go back to our list of polyatomics, and sulfate is SO4 -2. So we're going to write SO4 in parentheses and the 2 minus on the outside. Now remember, when they have that same numerical value, we can reduce it down to 1:1. So the formula then would be CuSO4. If you cross your charges, you would have Cu2, SO4, 2, and then we're reducing that to get the correct final answer.